I am about slowly to start the presentation. Welcome to my talk. It's nice to see you here. How are you? Oh, great. So, okay. So this will be really a sad presentation. So if you're feeling great, good, because now you need this like a little bit of happiness so that you can go down. Okay. So I am Jarek Ratajski. I'm software developer, wizard, and an architect. That's the last one. That's my position officially at Ingenious. I live in Switzerland. And of course, if you want to ask questions to this presentation, you probably know already the procedure, Slido.com and GeeCON. So why this presentation even? So I'm active on this Polish community page. It is a community of developers. Sometimes we call it like Polish Stack Overflow, although it's not really Stack Overflow because there are technical questions and answers, but a lot of this page is about community, what we do, how we evolve, so open questions and tough ones. So, and once in a while, there is something we call drama post there. Basically, mostly it happens in summer. I've seen that this is in Polish. So, but I will translate you in the next page. What is this? So, people are complaining that they always have new technologies to learn, and new frameworks, and new programming languages, and who even creates all those stupid niche languages? What for? And does it ever end? Because at the end they have families, other hobbies, and they are a little bit frustrated, like, maybe they should skip, maybe the developer job wasn't good because they thought they will learn at boot camp, university or whatever, and then learning will end and they will just enjoy life. Seems to not work that nice. And about it, there will be a presentation especially about these new languages. Why do we even have them? So do you remember your first programming language? So can you shout it for a moment? I will say 3, 2, 1, 3, 2, 1, shout! Yeah, of course. This was my basic. I've heard it. And a lot of people programmed. You've probably started with other languages if you are younger. But that was my first, literally first program. Sorry, Zenek. But basically, it was like the first program you create in BASIC that really does something interesting. You can probably guess. The point is this first language you've written something is your favorite now? Is it? Think about it. And what I mean by favorite language, it's something that you know well, of course, and you like it, but it's even more important that you dislike others. It's like, language is like religion. It's not, we are not a community of people that like each other. We are a community of people that hate all others. It's like nation, religion, or anything like that. We think others are worse. Okay? Sorry for that, but basically it happens. So, but of course, if you have favorite language, you would do everything in this language mostly, and you can probably even do that. So even if you are, if your favorite language is Java, you can even do web pages with Java, which some people consider crazy, but it's possible. Okay, so now shout your favorite language. I try to guess. 3, 2, 1, 0. Okay. Okay. I thought this is obvious. They really evolved. This is really the most popular language, so I thought it is an easy guess. But okay, there's a special page that I like. This is old. It comes from ancient times of internet. Very simple algorithm, write a song, lyrics of the song. It's a simple test. Can you write a loop in a language? It's not, a song is actually a real song called 99 Bottles of Beer. And the idea of this page, really, it's an amazing page. You go there and you check 1,500 different solutions for that in over 1,000 languages. There is a difference because some solutions are, if there is, for instance, like object-oriented solution and functional solution in a language, they count as 2. So you can go there. It's an amazing source of inspiration. How crazy things you can do that, and how many crazy languages are there. And yeah, how it even happened that we have this 1,500 is quite much. So let's go to the beginning with the hardware. Do you know what was the first computer? What is considered the first computer? Who guessed? Who can guess? ENIAC. Okay, I will tell you a story where ENIAC is quite at the end of it. So first computers, first thing that is considered to be computer, I'll tell you a short story, looked like this. Now, you know this? This is the part of it. Who knows what it is? Of course. So what's this?
Analytical engine.
Yeah, and how old is that?
200-ish.
It's about 200 years old. This was analytical engine from Charles Babbage, and the point is, first planned computer, he started to build it. The plans were mostly okay. It was never finished because at that time they didn't have precise machines to create all those gears precisely enough so that it would work with existing like steam engines, etc. So this machine was never finished, but it actually behaved. It was planned to work more or less on the same way that the modern computers are working, with the difference that inside, instead of electricity, all these things, chips, there would be real gears, wheels, and it would be powered by steam engine. That's like best thing if you are into steampunk, the best thing you can imagine. And this is, by the way, a very interesting story. So there is even first program. Actually, we have programs for this machine. They, in fact, you can get to, they are written on paper, and they are more like diagrams, but some people translated it, how it would work in, let's say, modern way of writing those programs. This is, let's say, translated to the modern way of writing it, first program probably ever, first more complex. Do you know who is the author of this program? Ada, of course. However, it's more complex story, because, of course, the author of the engine was, analytical engine, Charles, was also involved. That's not easy story, but as a symbol, she's considered the first programmer ever. So, and that's how it started. You know this machine? Probably not. Who has heard about it even? So, those guys in States created a machine. It was based, by the way, on, this time not gears anymore, electromagnetic relays, and relay switches. So it was noisy, it was very, very slow, but it was from 1939. Why we don't hear about it? Because the guys didn't actually understood that they created something new. That was just fancy toy they created. Only after ENIAC became popular, they realized, oh, we did it many years ago, and I actually fought for patents and everything, and I think they even won. You can read about this story. So they were given some patents for computers. Okay, so then this one. If you are in any German-speaking country, you know about this. You know why it wasn't famous in other countries? Yeah, that's okay. Konrad Zuse was just a scientist, but the year shows you that that was a tough time. Especially, of course, it was secret. And second, after the war was over, it wasn't very popular to say that they've created this already before us, before exactly US, or later appeared that also UK had some computers, also secret, which was published, I think, in 90s. But nevertheless, again, it was a little bit better machine than this before, but still with switches and, let's say, noisy and slow. Also, the interesting story, after the war, Zuse, he created the first high-level programming language, probably, but because of political reasons, it was basically ignored, and we will not talk about it. It was an interesting language, by the way. So then came all this story that, you know, Colossus, which was secret until recently, like 20 years ago, we've heard about it, I think, first time. That was the ENIAC, that was actually for years considered the first one, etc., etc. How programming looked at that time. So those are first how programming looked. I told you that this transcription of the first program with N1, this file, didn't really exactly look at that because there were no files. There were no text editors. Programming was a physical job that was really healthy, partially, although it was noisy and maybe the air conditions were not really great, but you had to really walk along those machines. So, and when you see pictures from that time, you will see a lot of women actually involved in programming, in switching and designing like that. That's also interesting. They were like, seemed to be dominating this industry at that time. Okay, and that how it looked. I will not show you on switches, how the first programs look like, but I will translate it again to the more modern computer, very modern, like 30 years after ENIAC. You can like create ENIAC like 0 year. 30 years after ENIAC, there was a computer created, let's say, that I know, because it was my first one. And let's analyze the code. Can you tell me what it does? This should be easy. No, OK. It would be easier if I tell you the processor, actually. I have to tell you this was 6510 machine. Now some of you should easily decode it. If I tell you that you have to put it in a specific address in memory, that should be even easier. And you see some patterns there. If you see that F0 there, up there is like conditional branch, so like if, let's say, that should be even easier now. No? Or for C, quite at the end. OK, not really at the end. It's unconditional jump. OK. This is what this language is. What's the name of this? Tell me. Shout it. It's not assembly. It's a machine code. So this is the language of the machines, how we say that right now. And to simplify it, actually it is a very simple language. It's one of the simplest you can master, let's say. Really, it has very specific set of rules. It's even modern machines, they are complex, but the language is quite simple. What is the problem of this language? You have to talk in numbers. And even you can learn those numbers. Let's say some of those numbers, they encode the opcodes, they encode what to do. Some of them encode addresses, relative addresses, etc. Calculating, especially those relative addresses, this is really boring and error-prone job. So this was easy language, but hard to program. Actually, I remember me programming that there was no single branch that I calculated correctly. I still remember that. If I tried to do something in machine code, always I was like one byte too high, too low. So people found this problem, and they decided to simplify their job. And they created this, another programming language that looked like that. Now, by the way, this is the same code that you've seen before, but in this language, which is obviously way more readable. What is this? This is assembly. So it's like human readable machine code. And you have, instead of calculating all those loops, how many bytes you skip up and down, you have labels, and this is all way more easy to understand. Do you now know what this program does? That should be very easy right now. Oh, come on. OK, but later. I will be mostly showing one code. So this was assembly, relatively early created, basically for noobs. Yeah. So what was good about assembly? For people that cared, and at that time, relay switches, they were slow. So performance was a problem. You were actually seeing or hearing each cycle of the machine. So it's better if a language didn't create any overhead. So assembly doesn't really create any overhead. You only have to compile it, and then you are still thinking about machine code. So, and the second thing that actually is interesting about assembly, in a history we see that it was partially portable. So it was like the same opcodes could be translated to different machines with a compiler, and it was first time that people see in like portability. It was very minimal portability, not perfect with problems, but still. But of course, now more problems were visible. We don't have variables basically in assembly. We have registers, and you have to remember which register is used for what. And you quickly realize this is a hell, especially doing arithmetic calculations and everything like that. And people realize they need a lot of comments. If I read now assembly code from the past, I see a lot of comments. That's actually where they were really needed, because you are using register X, A, B, C, but you always have to say what's exactly in this moment it means in order to preserve maintainability. OK, so, but the hardware was changing. Hardware was changing, and this thing happened. Do you know what is this? It has nothing with spaceships or whatever. This is a memory. This is a very interesting memory. It's from Wikipedia, the picture Wikipedia, and this is like mercury-based memory, where liquid mercury actually stores the bits, and it's stored as a waves in this mercury. So if you are working with this kind of computer, you would rather be silent. Otherwise, you can't you could erase memory, or if there was a train coming by, it could actually really erase them or completely put a noise inside it. So this was strange time, but the point is, in this Mercury, this was working as a delay line. It's really interesting to read how it was working. You could store way more data. So you could do bigger programs. So this means that there was opportunity to create another programming language, now more sophisticated than assembly. And this was this. Do you know what language is that? What? Yes, it's a FORTRAN. You can distinguish FORTRAN from other languages that the labels are numbers, but they don't really come in order. This is really interesting. And by the way, this is not the first version of FORTRAN. The first version of FORTRAN was even more crazy. So it was like very close to assembly. If you look how those things were decoded, actually people doing FORTRAN could think that they are not doing assembly, but still they were very close. It was like one of the most important things, especially of first FORTRANs, that the code, compiled code, is still very fast. I love the type system of FORTRAN. If a variable starts with I, j, k, l, n, it means it's integer. Otherwise, it's float. So it was designed to make mathematicians, scientists' life easier, because for years, they were encoding all the mathematical equations like that. Those are indices, those are other numbers. So it was like designed for people involved in mathematics. And they were doing a lot of algorithms with that. They were happy. Cool. Although there was a goal to have, of course. But mathematicians had their language, and other people that were not exactly doing mathematics, they realized they don't really like FORTRAN that much. They need something more for mortals. And they created other language. If I present this picture, you should know which one. COBOL, of course. This is a COBOL grandma. So Grace Hopper, she didn't really design COBOL. She was a part of this committee, but she designed the language that influenced COBOL. And you read, by the way, we are still doing the same thing. Now in COBOL, you should really see what we are doing. Move first number to displayed number. Perform varying ix from 1 by 1 until blah, blah, blah. And one thing about COBOL, you read it as English. Do you see that? It's really like English, but okay, military version, like a lot of ceremony on top. It's basically, yeah, it was created, let's say, by people involved in military stuff. So COBOL, again, very close to FORTRAN by design, just a little bit different language for business people, not really scientists. So if you complain that Java has a lot of ceremony, try COBOL for one day. You will then see that, oh, Java is like, and actually there were some, I don't really exactly remember the number, how many lines of code you need on average to represent the line in Java, and this was something more than 10 for sure. So it was really extreme ceremony. And the point, it was for clean code. You didn't need to comment this code, it was self-commenting. Although in reality, when I read COBOL code, I see a lot of comments, I don't know why. They are exactly as stupid as comments I see in Java. So mostly exactly repeating the thing that it's done below. But we see one thing, why people are creating those languages. Because there is a boring stuff like translating to machine code, which can be automated, and we do this automation because we just want to be faster. This is like original reason for first languages. It's clearly visible and obvious for everyone. But the hardware was changing. And yeah, that, by the way, hardware, I still remember those. I didn't use them, but when I was studying, there were still a lot of those cards floating everywhere. In the hardware, we had this. The, let's say, electromechanical relays were replaced by vacuum tubes, way more reliable and faster than the previous one, and less noisy. So we could create better machines. And what that means for us. The people were able to create more sophisticated languages. And they created this. Some of you should know this. Lisp, of course. This is crazy thing from 1958, quite interesting if you look at the concept that this was like original functional programming, the first functional programming for everybody. And basically, it was beautiful language that a lot of people are really charmed by how beautiful the Lisp concept is and how simple. It's like lambda calculus, by the way, so it's no wonder. But for some reasons, most of people didn't believe that you can actually do something in Lisp. And it was for years like academic language. It was used, but mostly in some crazy niche areas. But it shows one thing. With better machines, you can introduce new concept that was like functional programming, a specific flavor of functional programming. But now machines are good enough, and you create new language to test that. Basically, Lisp was kind of experiment that at the end appeared to be quite successful, but many, many years later. We'll not talk about Lisp, because it was actually Lisp is now coming back to life mostly. It was always there, but always as a niche. But there were other languages created, like this one. So, do you recognize this one? No? Okay, I can tell you. There was a FORTRAN created for mathematicians, COBOL for business people, and actually this is also for some group, for people that write algorithms, because actually the first languages created a new, let's say, brand new area, people involved in computer science, writing algorithms. The language is called ALGOL. It's an ALGOL, and it's, again, still close to FORTRAN. It's like better FORTRAN, especially the original version. Actually, it was a better FORTRAN. But it was really designed to write algorithms, computer algorithms. Like FORTRAN was for mathematical algorithms, this was more for computer. And it was like pseudocode of that time. And exactly, if you have any book from 60s, 70s, you will see that most of the algorithms, any sorting, this is all presented in kind of an ALGOL-like language. What about it? ALGOL 58 was just better FORTRAN. Then there was like very, very successful ALGOL 60. And then there was like ALGOL 68. But people for a few years thought that ALGOL is the ultimate language. We don't need anything better. This is just the best. And it appeared like that. For instance, ALGOL brought the first time recursion. And this is an interesting story because actually a lot of people involved in ALGOL community, ALGOL 60 didn't want it to have recursion, but it was complex to create a compiler that supports recursion. But some other people knew that recursion is actually a good thing, and they sneaked recursion concept into the definition of the language, so that the other people wouldn't notice, and later it was uncovered, and it was funny thing created by some smart people, so that others were forced to, in fact, support recursion. Okay, and then came ALGOL 68. It was just idea that ALGOL is so successful, let's make it even better, like ALGOL++. Really smart people gathered, created a committee, and they, all of them were very smart. All of them tried to put their best concept into it. And they created a language that has all concepts that you can imagine, supports all of them. This is, of course, a great idea. So I can only tell you that even while they were doing that, people were seeing it is a disaster. So if you complain on the languages that use a lot of funny operators, the ALGOL 68 supported so many operators as you see on this. This is like keyboard that you would need for ALGOL. Really cool. Really all defined in the language. Supported. Oh, even Scala is not that good right now. So the problem is, in reality, the machines, you were lucky if they supported a couple of more characters than the standard Latin letters. That is how typewriter, how typing looked like that time. I tell you, there are no such symbols there. So this was like really mismatch between reality and expectations. And this was the first language, basically, where for years no one could create a compiler that would fulfill all the definitions in the implement. Yeah, that was really a disaster. But hardware was changing while this was happening. This thing appeared. You know what's that? Core memory. I love this because I think this is the last memory where you really, by your own eye, can see the bit of information. It's really there on this net. So it's cool, but it meant you could store way more than in this Mercury, delay lines, etc. So, and this is thing that replaced vacuum tubes. So you know, it transistor. The original one wasn't even small. Actually, it was very big, but nevertheless. And this and disaster of ALGOL created the opportunity for a lot of languages. There was like, I would say, explosion of them. And this is, for instance, one of them that was created. Now I cannot really, till this moment, I was able to present most important languages. In this moment, I'm only choosing, because it was really, there was so many of them, it's not possible to describe even half that played some role. But this is chosen by me for some reason. You know this language? Probably not. No, no, but okay, close to, you will see why. Close, this is ALGOL W. Alternative, why people were seeing disaster coming with ALGOL 68, it has one concept, first time introduced here, null. You see there, nulls. This is actually the first language that introduced that, and that's a creator, Tony, that says it was his billion-dollar mistake, and he said that exactly he introduced null because it was easy, not because it was needed. So interesting. But of course, this is only one of the of hundreds probably, okay, maybe not hundreds, but 100 created languages. Then there was this one. I put it here because it is, if you are doing Java, you somehow started with this one. You know what is this? Close. BCPL. So it's like something that was before C, but was after B. It's like, yeah, that there was such language. It is interesting because it had only one type. So it was one type that was always the same as a machine word, so close to the, it was like representing the internal structure of your machine. If your machine was 16-bit, then the only type was something that has 16-bit. If your machine was 16-bit computer. If it would be 32 bits, it would have one type. All the variables would be 32 bits. And it's by concept similar to the like very first early C, and that was a system that first, okay, not first, but few of the computer systems were written with, because it was friendly for that. It was close to the OS programming. It was really handy for that, because of this fitting type system. So, but it needed something to fix this problem, because if your type system is so easy, you have one type, it's like you have nothing. You need to somehow to encode this information. What is this, in fact? So you do that in the name of the variable. That's hence the Hungarian notation comes. It's only needed in this kind of language. But I've seen the Hungarian notation in Java, which is really strange. Nevertheless, it happens. So then there was actually something else created. You know this language, of course. I presented BASIC. I think everybody knows BASIC, everybody BASIC. So created 1964. Why it's interesting? Because this was language for masses. It was language that was now friendly for hobbyists. And it became incredibly successful. Language that has interpreter, it was very slow, but on the other hand, it allowed people that were not professionals to analyze problems, debug things, and it was really breakthrough. So, of course, with some problems. Yeah. So that was the era of BASIC. Basically, it started with, of course, changes. We had chips now, so we could do even faster computers, like one of the first Intels you see here. And then, for instance, this machine was created, Altair 8800. By the way, you see something interesting. Programming of Altair, you had actually initially always do that with switches. So actually on top you see the programming was changing the switches up and down. You set bit or clear the bit, and that was done like that. After you programmed something, you were able to program loading of something from tape. So this machine supported tape readers, but you had to first program the loader of this tape. It was really interesting. But it wasn't really a lot of programming. Actually, in the original manual, there was written how to write loader. This computer had two heroes. You know them. Bill Gates, Paul Allen. They created the very successful BASIC for that. And that was like when computers become popular, microcomputers and everyone. And BASIC was, I started programming in the 90s. At that time, C was considered the most professional one, but still people were telling that actually everywhere is BASIC. Everybody is doing BASIC still. Which depends, of course, but most of the, probably the majority of programs were actually, in fact, written in BASIC, even in the 90s. So in the early 90s. But this guy came and published article like GoTo is considered harmful. I haven't seen that article at that time, but I've seen other people commenting on that there is this thing that we consider GoTo harmful. And actually, for me, it was like, what? This is the basic thing you do in programming. You jump from here and there. It's actually, without GoTo, it's not even possible to program anything. Like, what are you talking about? By the way, all those languages before basically, with the exception of Lisp, had some kind of goto. So what's the thing? So the problem is that goto creates the mess of your code. It's like you can jump from any point to any point. So of course, you may sooner or later have a spaghetti code, and it is a problem. Actually, I had this spaghetti code. I remember then I realized, oh, I really have this spaghetti problem. I cannot analyze my programs if they grow big with gotos. So there was idea how to solve. Let's introduce language that doesn't have goto and still work. This should you actually recognize, of course. Pascal, yeah? So this was like a proof that you can live without goto. No more goto, variables must be declared, so it was solving problems of the basic problems. And it was like a proof. So that shows the reason number 3 where you create language. You want to prevent some errors. You want to introduce maybe a new concept, like I already said that, but exactly your goal is to reduce number of human errors. And this is the thing. So actually, this created a structural programming where it's impossible to create spaghetti code, of course. OK, but meanwhile, the hardware was changing. We had these hard disks. It means we could create bigger and bigger programs and compile bigger and bigger stuff. And this language became popular. You should know this. It's a descendant of BCPL. Really, first programs, a lot of programs were translated, even compiled together with BCPL. So you know that. C. This is a great language, very successful even now. So inherited, let's say, this OS programming support. But by the way, if someone says that you can do OS programming only in C and only C supports that, actually there's nothing in language that supports low-level C operating system programming. Nothing like jumping from one security ring to another. Nothing about interrupt vectors. All of that stuff is done with special pragmas compiler directives. You could do them for any language, but actually C, partially by accidentally, was the one language. So now, if you do some low-level stuff for OSs, for Unix, you actually have to learn C anyhow. And this is the easiest to do something with that. OK, there are some other choices, but this is like standard one. OK, and you see a lot of problems. So C achieved something that was very great, really sensible portability. It had some problems with that. Even now, we see those problems. But that was like really portable language. We actually experience that every day. Because a lot of our machines are using the same common codes written in C. And of course, had a problem, especially this one life's too short for malloc. So some problems solved, other introduced. And people said we need other language. And you know this first functional language I was working with? What? C++. You really see this there in the code, sorting done with a functionally defined ordering. It's really functional language, so you can use some functional programming there, although it wasn't known for that. It was called object-oriented programming language with people involved that were involved in object-oriented, let's say, programming by definition, like ALGOL, were like asking, well, no, that's not really C++ what it is, but nevertheless, it's how people perceived it. So it had better, more friendly encapsulation than C++, but of course, it's than C. Solved some of the problems, but introduced or didn't solve other. So like, I really remember metaprogramming and operator overloading. This was something that created incredible possibilities to sabotage your projects so that no one will notice. OK. But meanwhile, the hardware was changing, and we had networks. And people realized, really going with C or C++ into network, this is what we do, but it is not very secure and error efficient. And this language was created. Now you should know that. What is this? This is, of course, Java, but this is one of the first versions of Java. Just admire for a moment how beautiful it is. Object-oriented programming. You see object there, and actually, at that time, late 90s, really, object was the most used word in Java, because you had to cast everything. If you were taking something from a list, you were getting object. And then were you checking for instance of, then you were casting. That was so beautiful. So Java breaks with C compatibility, but preserves the syntax more or less. It's similar. So it was easier to accept for people. I came from C++ world to Java, and for me it was like, oh, initially it looks more or less similar, it's just slower. And then, yeah, that was really a problem in late 90s, the speed of Java was really. So, of course, solved a lot of problems, especially some of you, garbage collector is one thing, but actually I had garbage collector in C++, that's not that tough. But it was just not good, but it was. But the thing is that what it gave us, it was a really better security and way better multi-threading than in C++. So that, but for one thing, I still cannot understand how this language could have even be considered efficient for people that were writing in Java 1.2. That's actually when the Java exploded. If I try to go back to this kind of coding, I get crazy in 5 minutes, really, for this casting, etc. But why the Java was so successful? Because it was for free, really. For the companies I worked at that time, it was one of the most important reasons. That was compiler, hold the platform, and everything for free. We choose it. It's just, really, because previously, when you were thinking about the language, you basically had to buy something. There was exception of C, C++, but even at that time, GNU C++ compiler was kind of weak. And libraries and everything you had to pay. Now people see, if you want to make it popular, you have to give it for free. And then later charge for it. There are companies doing that. Okay. Now the most successful language ever, you should easily recognize this. No, it's not. This is, of course, valid JavaScript. I love it. It was, I think, Hello World. This was the author of JavaScript. I don't, there is a reason why I don't put this black over his eyes. So actually, JavaScript in the core is quite beautiful and it's kind of a Lispy, I would call it. It's really functional programming. It's just some design compromises that made it ugly. It's a really wasted chance. Sorry, if you love JavaScript, sorry. It could have been better. It was so close, but no. OK, didn't happen. But why JavaScript was so successful? Because it was just put into the browser. And this is the first language a lot of people actually tried, because it was so easy to present something working in a browser, and it was there. So the reason number 5 I found, there is a niche. There's a special place where you use some language, and you put it, and then it becomes popular there. Like, for instance, scripting for game engines, etc. All of them created a lot of interesting languages, those places. But the hardware was changing. And this thing appeared. What this represents? This is like first multi-core processor. I'm not sure, first popular, let's say. Multi-core, so we had more cores on one single CPU. And this was the moment where people doing Java and all that stuff realized that sharing stuff in memory actually is not that fun and not that easy, even though you have a lot of things like synchronized keyword in Java. There was a problem. I still remember all those crazy problems that started to pop up in programs that we are using for years because they were not designed for multi-core. And there are a group of languages that actually for multi-core, they are still safe because they do not share, they do not mutate anything. You know this language? Haskell. So it was there even before Java, but for years it wasn't so popular. Only recently we realized functional programming is something that is safe, and it was way safer if you have multi-core processing, because it's by design safer. OK, but I'm slowly going to the end. Let's talk for a moment about JVM languages. We are on JVM mostly conference, so JVM languages. There are so many of them, like Groovy. Why do we have them? Because some people were not satisfied completely with Java. And they realized JVM is great, but Java has some problems. We'll talk about it. So Groovy, less ceremony, Clojure, which is like Lisp for JVM, Scala, which it's like ALGOL 68 of today's time, supports exactly everything. Or Kotlin for the people that were not good enough for Scala. OK. Or Ita, which is basically Haskell translated to JVM. And many more. Actually, we have a lot of JVM languages. This is so beautiful. Like, of course, the question, sorry, this is a Polish joke. Like, who would even need that? OK, so I tell you that this is a story that illustrates it. Actually, today there is like something that also interesting to this story. Like, I think that was a year ago, someone tweeted this. how do you do all these stupid tests that's, for instance, check for null, check for that the input argument is not string? That was a guy talking about JavaScript, particularly. And that's my best hero of tweets, Mario Fusco. His answer was like, library that makes all those stupid tests, it's called statically typed language. Exactly. So, and this is actually representing something that let's say, I see. If you want to have some quality, let's say you go for, let's say this is of course abstract number, some quality. You preserve this quality by either going into more tests or going to more sophisticated types. I will show you that probably in a few slides, but this is some kind of axis, and you can choose. And the point is, where do you think is Java on this axis? I would say it's in the middle. So you can actually do more in types than in Java, so that you write less crazy and stupid tests. Or you concentrate on testing what's really for business, not all, for instance, technical stuff. So now a little bit of code. Why Java is sometimes not the best thing you can imagine. Like, this is code, I'm finding person, then checking if it's not null, then finding department. If it's not null, then I assign a manager for this department, like everybody does it. The same thing in Kotlin. What we see in Kotlin, a little increment in a type system that nullability is a part of the type system. So we can really save a lot of code. It's exactly, if you don't know this, it's like compiler is checking. If something is nullable, it's actually, you end the type with a question mark, then compiler checks if you did if. If you don't do if, it says I cannot compile. It's exactly as in Java with checked exception. I cannot compile because you didn't catch this exception. And you have to not create the same mess as checked exception created in Java, you have special syntax to simplify, like this question mark dot, which simplifies. I'm check for null and then do this assignment. OK, this is Kotlin. On this code, you have a simple data structure, like a count with a couple of properties. And then, of course, in Java, you can have Lombok. Who uses Lombok? Great, great. I will tell you something about it later. And this is Lombok code. Actually, it's not really heavy Lomboked. I've seen better, where annotations were like, wow, to the sky. And of course, you do that because if you want a plain Java version without Lombok, you would even need a special display for that, so that it fits on the page. But in Kotlin, it's just this, let's say, more or less the same. You have a special syntax for that, which is short. By the way, Scala has the same with just a different name. And it's beautiful. And I tell you one thing, because I was in heavy Lomboked code. It's just ugly syntax for writing very pathetic Kotlin. And my opinion on Lombok, I was fascinated, but after a while, no. It's just so ugly that you cannot write beautiful programs with Kotlin, because with Java and Lombok, because this ugliness goes to your heart and basically makes you covered in something that you smells badly. OK, you need a shower. So who knows that we have vars in Java right now? Great thing. You can simplify the code a little bit because of type inference. But the problem is var in Java is something added artificially to this. Like, it doesn't fit to all that stuff, because normally in Java we first have a type, then the name of the variable, and now var, which looks a little bit different, awkward. Look at this in Kotlin. There we have only vars and vals, the same in Scala, and we can do that for fields, for parameters, for everything. One syntax. So actually, at the end, Kotlin is, let's say, richer in, we can do more stuff, but with, let's say, simpler syntax. Isn't it good? So because simply, if you put some stuff to language, after a while, it's like exactly this project that you kept for 20 years. Initially, it was nice, but after 20 years, you add features, it loses some, let's say, consistency. OK. But one thing, let's say you are actually now good with Java, and you do functional programming because you realized with immutability, with reactive programming, it's so cool. This is example from presentation showcase why reactive programming actually sucks sometimes. Code you would write in Java, in Kotlin would be very similar. Some abstract code. Oh, you see a lot of flat mapping. Is it readable? So actually, Tomasz Nurkiewicz represents the same thing created without reactive programming, which is way more readable, I can tell you, even though I consider it's not as safe. This has some safety, let's say. But there is a solution for that. use the better language, like Scala, which supports for comprehension. And then it's very similar to the imperative code. But now it's like you eat cookie and you have cookie. You are reactive, you have safety of the types, and you still have more readable code. Because if you would replace those arrows with equality, it would be like a corresponding code in done imperative style. So cool. But we can do even more. If you are doing anything like event handling and event sourcing, one moment we will create something called event handler. Like we have some state of aggregate of object, then comes an event of some type, and we just calculate the new state of object. We have maybe 10 such events, we just do one by one, apply them. What is very important about event handler, they have to behave consistently. If you do it today or tomorrow, from one state A, like maybe empty object, with some event, it should create exactly same result, no matter which time you do that, at night, at day, whatever. Why? Because you do this recreation maybe a few times, and if you would for some reason have a different state, then all the calculations, maybe emails sent to customer would be different. There would be a mismatch. But the problem is, in Java, Scala, you can implement this interface, but nothing prevents you from doing inside of this code, like local date now. I have seen many times such things broken by using of actual time. Oh, come on, you can't even test it perfectly, but what happens if you do it next day? You get a different result, like a transfer was done on a different day. Now the customers are very surprised if you use that. So can you even prevent that? So the point is, in Haskell, whenever you access date, let's say this interface is like definition of the function above. Whenever you ask for date or random or something like which is dirty, you are dirty in a type system. You became this IO monad, you get this IO monad, and your result is inside IO monad, and you can't take it out. So actually, in Haskell, you cannot fulfill this definition, this interface, if you do some dirty stuff, because you will have this IO monad, and you cannot take the result out of it. If you want to say that actually you are allowed to do some IO inside, you would have to say that the result of this function just at the end, on the top line, is IO of my aggregate. So you have a safe way to say that function is pure or does some dirty stuff. You can say, as an architect, for instance, I allow here to make dirty stuff, and here it's just not allowed. Will be enforced by compiler. No need for reviews, etc. So the point here is, most of you probably didn't even thought about this problem, that there is such problem, and you can fix it. Because languages change the way we think. For instance, this is about Inuits, and some people say they have 400 different words for a snow. I tried to find those words and realized that they are basically never published because they are not polite. If you live in a snow, you don't have nice words for that. So I will give you an example. Do you remember the world without mobile phones? I do remember. How was to organize an event? We go to the pub after the work or after the school, whatever. The pub after the school, okay, no. But nevertheless, we're going somewhere. Organizing this without mobile phones was a nightmare. But we didn't know it as a nightmare, because we didn't even thought there is other possibility. There's like maybe call, go to the people directly, go with a bus, then you get there to your colleague, and you see he's not at home. How cool. Then you give a message to his mother, and then, yeah, this is, if I was back to 90s right now, I would not go to any meeting because I would know it's impossible to organize anything. Now, because now I know how it can be done better. So you don't know typically that you are suffering something. If you learn a new language, you will maybe see that. But it's not always that easy that you just learn something, because mastering languages is also dangerous. If you go one language, maybe you are just better and better in that, slowly you're learning. That's, let's say, in some point you become more or less consistent. You don't learn more. If you start learning a second thing, this is more or less showing me on top Java and below Scala. Initially, some successes, then, oh, this Scala all sucks. They are so disappointed, so this below. But then I realized, even before mastering Scala, I became better Java programmer. This is the top line. And then something wrong happened. After I did more Scala, I started to hate Java. This is dangerous. OK, so the thing is, of course, you don't go with a fresh language to production, but you have a lot of opportunities in life. You do prototypes. You have trainings, hackathons, open source projects. Why would you do that in the same language that you program every day? That's a wasted opportunity to learn something new. And I say, this is 5 years out of nothing. But if you are in one language for 5 years, maybe it's a good time to learn something different. I mean different. Switching, for instance, from Java to C#, it's not switching anything. This is a nonsense. Really, OK, a little bit, but it's really, you will learn maybe other libraries. So what about architects? This is a problem. We have architects that don't let us. Grace Hopper, she written that. It's easier to ask for forgiveness than it is to get permission, so just don't ask and do whatever you want. Will there ever be ultimate language? Probably no. Why? Because we have new hardware, that's this box on the left, then we can try new ideas. If we try new ideas, we introduce new bugs that we have never imagined before. If we have new bugs, we introduce ceremony to prevent us from bugs. When we have too much ceremony, we simplify that. And when we are at the end of this cycle, then new hardware appears, and yeah, it repeats. So sorry, I will make 2 minutes longer. What if you just have family and want to quit from that? You can do that. But please concentrate on maintenance, and don't tell other people, maybe you are this architect, that they cannot do anything new. You are just blocking. You don't want to do that, don't do that. There are plenty of projects, maintenance. You can concentrate on them, get a good money. On the other hand, if you are just early adopter, like me, I would try a lot of these languages. We have to be responsible. We have to help people. We have to organize training, talks like this. Show why would you like to do this language. No, Scala is just better, Kotlin is just better, whatever. You have to convince the team why. You have to show those cases. And OK, that's enough for this talk. Remember, the languages were not there to make you angry. Actually, they are to fix problems, to make your weekends better, of course, at the cost that you will learn something from time to time. Sorry for that. Now the point, if we have questions, hopefully. Oh, OK, why I skipped Polish joke. It wasn't polished enough, OK? What did you mention? OK, sorry for that. I didn't have time. Yes, there is a quantum computing language, Q#. You can check that I have never created. Why you hate Lombok? I was in a heavy Lombok project. I can tell you, I hate myself and everything I did there. OK, thank you.